As we move to Chapter 10, Section 5, we're going to talk about how to graph square root functions. We've been talking a lot about how to solve them, how to add them, how to multiply, how to divide them. Now we're actually going to move to an XY chart and learn how to graph them. Let's take a look at this key concept down here. Do you guys see our square root function? Doesn't it appear to you? I'm going to flip it like that. Can you guys kind of see how it's almost, let's write this down. It's like half of a parabola. Absolutely, it's like half of a parabola. That's because x squareds are parabolas. And then what's the square root? A square root of x is just the positive side of an x squared. So it makes sense, I hope, a little bit that we're just talking about almost half of a parabola. Now, because we have this thing called the parent function, you guys see the parent function right here? What we like to do for these numbers over here, I'm going to star my favorite numbers. We try to pick perfect squares to plug in. So your book did pick 2, but when you pick 0, 1, 4, and 9, these are all perfect squares. Because the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. These are the perfect values to pick for x. So we're going to write pick perfect squares for x. And I'm going to teach you if you ever have to change that fundamental thinking. What have we learned about the inside of radicals? Hopefully, you've learned that the inside cannot be negative. Okay? If the inside cannot be negative, that means that we are limited. Okay? Let's take a look at problem 1. It says finding the domain of a square root. Now, since we have a square root, we need to think to ourselves, we're limited for x. Why are we limited for x? Because the square root cannot be negative inside. If the square root cannot be negative inside, what does that imply? What can the smallest value be? Hopefully you're thinking to yourself, the smallest value that it can be is 0. I'm going to write the smallest possible is 0. So I'm going to take all of this stuff inside. And what I'm going to do is I'm going to set it greater than or equal to 0. Because the stuff inside has to be positive. So if I add 9, I get 3x has to be greater than or equal to 9. If I divide by 3, I get x has to be greater than or equal to 3. This is the domain. The domain is x has to be greater than or equal to 3. How else could you write it? You could say it can be equal to 3, or it can go to positive infinity. Both of these are solutions. Okay, you got to be able to see both ways. You never know what might be on the keystones. You might see that on the keystone, or you might see that on the keystone. They mean the same thing when you talk about your domain. Let's try again in the got it. The stuff inside, that's the stuff, has to be bigger than or equal to 0 because you can't take the square root of a negative. Take away 5, divide by -2. Now you guys got to remember, make a star here, when divide by a negative, flip the sign. Okay? When divide by a negative, flip your sign. So x actually has to be smaller than or equal to 5 halves. Now let's think about what that means. That's the domain. What's another way of seeing this? Okay, 5 halves would be the biggest. and you could plug anything smaller in for it, smallest to biggest. Take a look at the difference between these two. If you have problems, especially with the interval notation, come back and ask some questions. Problem 2. We finally get to graph some of these. Graph the function I equals 1/5 of P, which gives the current I in amperes of a certain circuit with P watts of power. When will the current exceed 2? Alright, so we've got a pretty big equation. Now what's nice is since we have the graph, let's go ahead and plug in these different values. But I'm going to cheat, and I am going to plug in the perfect squares. So I'm going to start with plugging in 0. Next, I'm going to plug in, what's another perfect square around here? What about 36? That would be a pretty nice one since there's a square root of 36. How about 81? And how about 100? That way we'll get a pretty nice graph when we go to do this. Let's plug in 0. We do 1/5 of the square root of 0. Well, that equals 0. Let's go next. 1/5 of the square root of 36. Well, that's really just 1/5 of 6, right? Well, 1/5 divided by 6 is 6/5. Or if you want a decimal, what's 6/5 as a decimal? 1.2. So it's not growing very much there. Let's go to 81. I equals, I don't have to write the I guess I know it is an I. 1/5 of the square root of 81. Well, that is 9/5 because of the square root of 81 being 9. 9/5 is 1.8. Let's do 100. 1/5 of the square root of 100 is 10/5 because of the square root of 100, which is 2. Let's plot our points. 0, 0, that should make sense. 36, 1.2. Here's 35-ish, so I'm going to go up. It's 1.5, so right around here. Okay. 81, 1.8. In 102. You can see how we have that shape. It's almost a parabolic shape. I like to turn my paper, it helps me. It's going to have the shape of a parabola. Okay? So if you need to turn it, because you guys are pretty good at making parabola shapes, you can turn it and make a parabolic shape. Now that is your square root function. Let's take a look at it. The graph represents the same exact one that we just had. And it says, well, we should probably go up here. It says, when will the current exceed 2? Well, look here how we got 2. Does everybody see that? Since we actually got the value of 2, we're going to say it will exceed 2 after 100 amps. Okay? And that would be, oh no, I'm sorry, it's not 100 amps. It will exceed 2 amps after 100 watts. Excuse me, I had my X and Y's backwards. Alright, now we gotta do 1.5 again. Now they have the graph already done for us. So what I'm gonna do, I'm gonna cheat, I'm gonna get a popsicle stick. I'm gonna go to 1.5. Can we all see 1.5 right there? Where does 1.5 occur? Well, 1.5 seems to occur right around 50. And that would be 50 watts. Now how can we check and see how correct we are? We're just going to go to our calculator and let's try 50, okay? Let's do 1/5 of the square root of 50. Let's see how close we are to getting, what did they want it to be? 1.5. That's pretty close. If you wanted to kind of play around with it and get it perfect, you could do that. And in fact, well, you guys are my honors group, let's go ahead and get it perfect, okay? They want it to be 1.5, so we'll do, ready, here's our equation. We'll do, when does 1.5 equal 1/5 of the square root of the power that I'm trying to get. Well, guys, we've learned how to solve for these. Do you remember? Let's multiply both sides by 5. That's going to cancel with that 5. And 1.5 times 5 is 7.5. That equals the square root of p. So now let's square both sides. 7.5 squared is 56.25, and this is in watts. So were we pretty close with our guess of 50? Yeah, pretty close, but it's much better to solve when we can solve. Do you want to see how, if you need to see this redone, I'm going to do it up here too as well to prove that it's 2. Because we could have said this. We said if we needed to get a 2, that equals 1/5 the square root of p, multiply both sides by 5, we'll get 10 equals the square root of p. Just like you learned before, you would square both sides and get 100 watts equals p. Alright? We'll learn how to graph. We're going to learn how to move them up, down, left, and right in the next video.